Okay, so before we jump into graphing, we need to talk about multiplicity real quick. So just a reminder, multiplicity is like if we have this function y equals, I'm just going to say a because I don't know if it has an actual coefficient, a times x plus 2 cubed times x minus 1 squared times x minus 3. So when we're talking about multiplicity, that would mean we would be saying that x plus 2 is a factor of multiplicity 3. So it's the amount of times that factor shows up, and that's multiplicity. So then x minus 1 is multiplicity 2, etc. So looking at this function, I kind of gave it away because I came up with the equation already, but the first part says this function has a 0 of multiplicity 1 at x equals. So we know that this is the factor of multiplicity 1, right? So that's going to be right here. This is at x equals 3. And the reason we know this, if we didn't know the equation, it goes straight through the point. See how it doesn't squiggle or it doesn't have a parabolic shape? It just goes right through. That's how we know it's multiplicity 1. That only happens for multiplicity 1, so it goes straight through like that. Multiplicity 2 looks different. So if you have something that's a multiplicity 2, or we'll see later, any even number, it's going to bounce back like a parabola. And that makes sense, right? Because it's going to be, the sign's not going to change when it goes from negative to positive or positive to negative, etc. So then our multiplicity 2 is at x equals 1, right? So, and we know that because it bounces back. And then the last type of multiplicity is an odd number multiplicity, except for 1, which is the first one. A multiplicity of 3 in this function we see is x plus 2 equals 3. So this is right here, x equals negative 2. This is where we have a multiplicity of 3. And we know, if we didn't know the equation, we would know that it has a multiplicity of 3 because it squiggles through. And so if we, yes, squiggles is a mathematical term. So if we hadn't known the equation at the beginning, we would have been able to make that equation just by looking at this graph, because we know, okay, this squiggles through, it's an odd number. This one bounces back, so it's an even number. And this one goes straight through, so it's just multiplicity 1. I guess there wasn't really a way to know if this was squared or to the 4th or to the 6th, but if we look down here, it is true that multiplicity 4, 6, 8, etc., they all look like a multiplicity. And multiplicity of 5, 7, 9, etc., all look like a multiplicity of 3. So that is to say there's really only 3 types of ways that the lines go through. There is the squiggle through, like you would see on an x cubed function. And then this would be like the 0 right here. It squiggles through. And then there's the bounce back. And then there's the point and the straight through. So those are the 3 types of ways multiplicities act. So we'll be able to use that when we graph. And so now we're looking at graphing. Okay, so the first step in graphing polynomials, we're going to use this polynomial right here as an example, is going to be to factor it if necessary. This one's already factored, so we're going to just skip that step. But as we learned in the last couple classes how to factor, you know how to do that now. So there's no work to be done here. And then the second step is going to be to find the x-intercepts, or the zeros, right? So looking at this equation, I'm seeing the 0 here is negative 2. This one is positive 3. And then this one is just 0. So then those are my x-intercepts. So I'm going to mark them down as 0, 0, 3, 0, and negative 2, 0. Okay, so now that I have the x-intercepts, that's the first thing I know about the graph. I'm going to go mark these on my x-axis. So here's my first point. Second point's at 3, 0. and the third one's at -2, 0. So the next step now is going to be to check the end behavior, because that's going to tell me where the arrows go at the beginning and the end. So I'm going to put check end behavior. And in this case, we have a negative coefficient, and our degree is, let's see, 3 plus 2 is 5, plus 1 is 6. 6 is even, so that's an even degree. So now let's look at our end behavior notes. We've got a negative leading coefficient and an even degree, so this is what it's going to look like. We're going to have both arrows pointing down. So going back here, got both arrows down, so then it's going to be something like, we can draw these and then maybe make them better later. So we've got both arrows pointing down. Next step is to look at the multiplicities at each point. So for the first point where x equals -2, the multiplicity is 1, because there's no exponent or anything. So if it's a multiplicity of 1, we can look back at our multiplicities. Remember, multiplicity of 1 goes straight through. So then this one's going to be a line straight through. And something to note about graphing this way, we don't know how high these things go. It could go up here, it could go here. This is kind of something we're just eyeballing when we're doing these kind of sketches. So as long as it goes like that, obviously it's going to come back to this point and either bounce back or go through in some way, so we'll head it downwards. The next point is that one at 0, 0. It's a multiplicity of 3. So if we look back here, a multiplicity of 3 squiggles through. So this is going to go up, and then it's going to do like a little cubic graph type of squiggle. We're going to come back up towards that one, and then the last one is -2, 0. Sorry, it's 3, 0. So then and then 3, 0 is a multiplicity of 2. So again, we can check back here. Multiplicities of 2 bounce back. So I chose a function that had all 3 types. And so that's what the graph looks like. And those are our steps. There's really not a whole lot. Maybe I'll fill in this step 4 real quick. Actually, yeah, I'm going to put it on the graph instead. Straight through, squiggle, bounce back. And that is how you graph a polynomial.